Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. In this video, I will explain about 2.3 about the addition rules for probability. So for the addition rules, when we are dealing with the union, when we are dealing with the union of two events, when you have A union B, so either we will have to find the probability of for event A or event B, or both event A and B occur. So if you look at this Venn diagram, so you'll have this is the area of A union B. So for this part, we are going to apply the addition rules. In our case here, this is the example of not mutually exclusive event. Why it is not mutually exclusive? Because here we have the intersection between event A and event B. So we have the intersection between A and B here, it is not equals to 0. The probability of A and B, it is not equals to 0. Therefore, it is the not mutually exclusive events. We look at the addition rules. We have here probability of A or B. So we can use the symbol of union, A union B. So we have to add PA plus PB, and then we have to minus the intersection. So there we have only one intersection of A and B here. And the second event is the mutually exclusive event. Here when you have totally separated for events A and event B, like this. So when you want to find the addition rules, or you want to find the probability of A union B, so we just add probability of A plus probability of B. A union B. So we have here PA plus PB minus the intersection. But if you look at the intersection here, it is equals to 0. So therefore, we can ignore this intersection. It is equals to 0. And we will get to use this formula only when the events A and B are mutually exclusive. So you can look at example number 1 here, where we have an event of get a number greater than 3 and get a number which is less than 3. So if you look at the elements, there is no intersection between event A and B. Intersection A and B, it is equals to 0. Therefore, it is mutually exclusive events, right? So if you have more than 2 mutually exclusive events, so we just add. Example, if you have event A, event B, and event C, so this is A, this is B, and this is event C. All of them are mutually exclusive. Now we want to find the union, or we want to perform the addition rules for these 3 events. Therefore, we just add all the probabilities. Done. Now we look at example number 2. A furniture store decides to select a month for its annual sale. So what is the probability? Find the probability that it will be April or May. If you look at the probability of April or May, so we have here the month is totally separated, which they are mutually exclusive events. So we just add the probability of getting April and the probability of getting May. So we have here 1 over 12 plus 1 over 12 equals to 2 over 12, which is 1 over 6. So this is the probability for getting April or May, because we assume that all months have equal probability of being selected. In a year, we have 12 months, right? So for getting April, it is 1 over 12. For getting May, we have 1 over 12. Next is when we have at a particular school with 200 male students, 58 play football, 40 play basketball, and 8 play boats. What is the probability that a randomly selected male student plays neither sport? So in this question, we need to set up a table. And no need a table actually. We need to set up a Venn diagram. it will be easier for us to look at the Venn diagram. Let's say this is the event for the male student playing football. So this is F. And this is the event for the male student playing basketball. And this is the intersection between them. So we have, this is 8 playing boats. We have 8 here. Playing basketball, we have here 40. And here play football, we have here 58. So now we have the total number of male student is 200 male student. So outside of this union is actually the probability, we can get the probability of male student that plays neither sport. So we can find the probability of the male student playing football or basketball first. So we have probability of F plus probability of B minus the intersection football and basketball. So we have here 58 over 200 plus 40 over 200 minus 8 over 200. Then you get 0. Okay, please check. 58 plus 40 minus 8. Okay, 90 over 200. Or we have here 9 over 20. You may leave your answer in decimal 0.45. This is when the male student plays both, okay, football or basketball. But now we want to find neither sport. It means that not football or basketball. So we have to take 1 minus 0.45. So we have here 0.55. Okay, then this is for example number 3. And the next is, okay, in example number 4, where we have a grocery store employs cashier, stock clerks and daily personnel. The distribution of employees according to the marital status is shown here. So we have, this is the cashier, stock clerks and daily personnel. So we have, this is married, this is not married. Total for married 23, total for not married 22. So total frequency overall we have how many employees? Yes, 45. Okay, then for daily personnel we have 5, for stock clerk we have 27, for cashiers we have 13. Now we want to find the probability if we select an employee, the probability that the employee is a stock clerk or married. Okay, stock clerk or married. So we have to write using the symbol stock clerk, maybe we can use S, or married M. So write the addition rules. Formula PS plus PM minus probability of S and M. So we have here PS, probability of stock clerk, it is 27 over 45. And then plus weight, probability of merit, it is 23 over 45. And then minus the intersection. How to find the intersection? You can simply look at the contingency table. For stock clerk and merit, we have here 12. Okay, so we have here, this is 12 over 45, stock clerk and merit. Okay, please calculate 27 plus 23 minus 12. So we have here 38 over 45, 38 over 45, 0.844, or you may leave in fraction also. 38 over 45, 38 over 45, 0.844. The second is the employee is not married. So employee is not married, we can use M bar. So we can simply take the total of not married is 22. 22 over 45. 22 divided by 45 equals to 0.489. Right? Okay. And the last one, question C. The employee is a cashier or is not married. How to write in the probability notation? We can use C or we can use union. Not married, we can use M bar. Then we have, this is PC plus P, M bar minus with the cashier and not married. Okay, so for PC we have 13 over 45 plus not married 22 over 45 minus, how about the intersection? Intersection, you have to look at the contingency table where we have here C and not married, we have here 5. C and not married, right? So we have here, this is 5 over 45. Okay, please calculate 13 plus 22 minus 5 over 45. So we have here 0.67, 0.667, and you may leave in fraction number which is 2 over 3. Okay, done? Right. Okay, so for this example 5, I'm already explained in my YouTube video. You can refer to the solution in the YouTube video. Inshallah, you can see for a solution for example 5 and also solution for example 6. Right? So with that, thank you and Assalamualaikum. Bye.